All right, so for number 20, when you're asking to state the domain of an equation, remember we're trying to figure out what are the exclusions that are not going to work. Okay, so we see that we have a square root in there. So what are the only types of numbers we can take the square root of? 0 and anything that is positive, right? So we know that the square root has to be something, the radicand, what's underneath that square root, has to be something greater than or equal to 0. But since that radical is in the denominator of a function, can it equal 0? No. So we're just saying, okay, well, our radicand then has to be strictly greater than 0. It can't be equal to it this time. All right, so in this case then, we would subtract 2, and we would get x is greater than negative 2. We do want to write that then as an interval. If you are struggling writing that as an interval, you can always go ahead and create a number line. This would be a negative 2 with an open dot, and greater than negative 2 would be going this way. So your interval will be a parenthesis with the negative 2 because, again, it's not equal to negative 2, and then it's going to go right forever to infinity. So that should be your answer for that one. Any questions from the homework last night? Yeah. Yep, and we actually are going to go over that again, but I can do that right now as well. So for 25, you would set each of those greater than or equal to 0 because they can equal 0 because they're not in the denominator. And so I get x is greater than 2, or x is greater than or equal to negative 3. So the way I showed you yesterday is that you had to make sure the answer worked for both of them. So if I plug 2 in here, 2 minus 2 is 0. I can take the square root of 0. 2 plus 3 is 5. I can take the square root of 5. So this one works for both of them. And if I look at my other answer, if I plug negative 3 in here, negative 3 minus 2 is negative 5, and I can't take the square root of negative 5. So my answer is going to be just this one. The other way you can think about it is if you think of a number line. Here is 2 with a closed dot. Here's negative 3 with an open dot. So greater than 2 would be going this way, and greater than negative 3 would be going this way. So it has to be like the overlap or the intersect. If you remember intersects from when we did set notation, it has to be where they're both happening. So they're both happening when x is greater than or equal to 2. So when we're doing our domain and interval notation, it would be bracket 2 to infinity. Yeah. It should be a closed dot too. Sorry. I'm feeling my pen wasn't working on that one. Yep, 27. We can't be positive 5. Okay. So x cannot equal positive 5 because 5 minus 5 would be 0. We also have to make sure that this is greater than or equal to 0. So that when I solve that, I'd have x is greater than or equal to 2. So I need something that's greater than or equal to 2 and not equal to 5. So thinking of a number line, I'd have a closed dot on 2. Greater than 2 is going this way, but along the way, I'm going to have a 5 here with an open dot. So it's just going to be like this. And then you go with writing it from there. Okay. So it'd be 2 bracket 2 to 5 with a parenthesis, and then parenthesis 5 to infinity. Okay. All right. Then we are going to go on to the next section. You're right there, Noah. All right, so we're going to combine functions in this section. So we're going to be adding functions together, find the difference, the product, and the quotient. So when we're asked to find the sum of two functions, you're going to see it as parenthesis f plus g of x. So it'll be f plus g of x. That's how we write it. And the way we find f plus g of x is we do the f function plus the g function. Did you do the homework? To find the difference means we're subtracting, so we'd call that f minus g of x. And for that, we're just doing f of x minus g of x. Notice how I put the g of x in brackets? Because I have to subtract that whole quantity. So you want to put the g function in brackets, and then you'll have to distribute the negative sign through it. To find the product, we would do f times g of x, and that just means we're taking the f function, f of x times the g of x. And then to do the quotient, we'd be doing f divided by g of x, and that means we're taking the f function, f of x, and dividing it by the g of x function. And of course, we got to make sure that the g of x does not equal 0. All right, so here's our first checkpoint. You want to write down the original two functions. So our first function is f of x equals x minus 5. The g of x is equal to x squared minus 1. And we're going to do all those operations with those two functions. So for letter A, when we do f plus g of x, remember that means we're taking the f of x function and adding to it the g of x function. So the f of x function is x minus 5. The g of x function is x squared minus 1, and I'm just putting a plus sign between them. So you need to combine any like terms that you might have. And we'll write our final answer as f plus g of x equals x squared plus x minus 6. Okay, so we're combining our like terms, writing it in standard form, and our last step should have that proper notation, f plus g of x equals. When we do this letter B, if we're doing f minus g of x, that means we're taking the f of x function and we're subtracting the g of x function. So f of x equals x minus 5. G of x, so I put minus, and then I'm subtracting the entire g of x function, x squared minus 1. So it's important that you put that g of x function in brackets or parentheses, because that means we have to distribute the negative sign through. So I get x minus 5 minus x squared plus 1. So I end up getting f minus g of x. Combine our like terms and put in standard form. Negative x squared x minus 4. Also, we do need to find the domains for these. It says that in the directions. Just forgot that for the first one. Both of these final functions are going to create what kind of a graph? Parabola, right? So remember, parabolas look like U's. Are there any restrictions on the parabolas? No. So their domain for all parabolas go from negative infinity to infinity. All right, letter C. Now we're going to multiply the two functions. So f times g of x means we're taking f of x times g of x. So f of x is x minus 5. G of x is x squared minus 1. We are going to have to FOIL this. So when I FOIL this, x times x squared is x cubed. X times negative 1 is negative x. Negative 5 times x squared is negative 5x squared. Negative 5 times negative 1 is positive 5. And of course, we're going to combine any like terms, which we don't have any, but we are going to write it in standard form. So f times g of x equals x cubed minus 5x squared minus x plus 5. Again, we need to find the domain for this one. So this parent graph is x cubed, okay, because there's a cubic there. Is there any restrictions on the x cubed graph? Nope. So again, that's going to be negative infinity to infinity. And then last, we're going to do f divided by g of x. So remember, that means we're going to take the f of x function divided by the g of x function. So f of x is x minus 5. G of x is x squared minus 1. So this is a rational expression. We're going to need to do what to the bottom? We got to factor it, because we're looking for an exclusion. We're looking for what numbers do not work. So when I do that, I get x minus 5. And then on the bottom, it's difference of squares. So we'd be at x plus 1 and x minus 1. We can't cancel anything out, so that would be our answer. That would be equal to f of g, f divided by g of x. And we still need our domain, though. So if we're thinking about this domain, first off, what are the exclusions? What's not going to work? Right, negative 1, positive 1 will not work. So again, if you struggle, you can always make a number line. So here's positive 1 with an open dot. Here's negative 1 with an open dot. And the shading will be to the left, in the middle, and to the right. It's just not those three values. Or radicals, yes, square roots. So we're going from negative infinity to -1, a parenthesis because it's an open dot. We put our union symbol, -1 to 1. Put our union symbol, and then 1 to infinity. All right, next one. We have two radical equations, so it's kind of like the example we went over from the homework. We're going to be adding f of x plus g of x. That's what A says. And then we're finding the domain of f plus g. So remember, f of x plus g of x means you're taking the f of x function, adding to it the g of x function. So f of x is the square root of x minus 3. Subtracting from that the square root of x plus 1. Now remember, yeah. Yes, I don't know why I still put a minus sign. Thanks, Elias. Plus. You know what? I think I might have put a plus sign, but it didn't. The marker is like super slow right now. There's a plus sign right here. All right, so square root of both of those. Remember, you can only add like radicals. Do we have like radicals underneath there? No, they're not the same. So guess what? We can't do anything else. This would be our answer. So f plus g of x equals. Then part B is asking for the domain of this. So it's like that problem we went over from the homework. Remember, radicals, they can equal 0 or positive, but they can't equal negative. So I'm going to set each of these radicands greater than or equal to 0. And so when I add 3, I would say x is greater than or equal to 3. Subtract 1, x is greater than or equal to -1. So again, the domain has to be true for both of them. So what you could do is plug 3 in for both. 3 minus 3 is 0. I can take the square root of that. 3 plus 1 is 4. I can take the square root of 4. When I plug -1 in, -1 minus 3 is -4. I can't take the square root of that. So therefore, we'd have to use this value. The other way you could do it, if you don't like plugging it in, make your number line. Here's the -1. It would be a closed dot here. Here's the 3. It would be a closed dot here. You want the double shading. So greater than 3 would be going this way, and greater than -1 would be going this way. The only inequality that has the double shading is the greater than or equal to 3. So therefore, our domain would be +3 with the bracket to infinity. All right, so you're going to practice doing these. It's page 310, 31 to 47, every other odd. So remember, every other odd means you skip. So 31, you skip 33, you do 35. And you're combining, the directions say to combine, and you're finding the domain. Okay, so here's 31, you skip 33, you do 35. Skip 37, do 39. So there's the first 3 there. You're probably going to want to get your book out, because remember, it's a good idea as you go along to check the back of the book for the answer as well. Make sure you're doing it right along the way.